So guys, do you remember for 9? I think that's the last time that you actually did transformations as like a chapter. I'm talking about shifting like a point or shape to the left. They call those translations. And then you did reflections, and I think you might have done rotations as well. They've actually taken rotations out of the syllabus, but I think when you were in grade 9, you still did it. Okay, so we're going to do those types of things. But then we're also going to talk about shifting the graph up or down, shifting the graph to the left or the right, and we need to remember what that is going to do to the equations. Okay, so I'm just going to write the standard forms again. I know we've written them down a bunch of times, but it is useful to just be able to recap what kind of shift does what to the equation. All right, so for y equals a sine k x minus p plus q. And then we have the same for sine and cos, or sorry, for cos and tan. So we're going to do y equals a cos k x minus p plus q, and y equals a tan k times x minus p plus q. Okay, we're just going to recap quickly what each of these variables do to the graph. All right, so we know that the a value stretches the graph. And it is usually the amplitude, but remember a tan graph doesn't have an amplitude, but a tan graph can still be stretched. All right, depending on where point 2 is, that whole y coordinate of the second point. And then also, if a is negative, that means that the direction has changed. But instead of saying that, we can also say that the graph reflected in the x-axis. I'll show you now. Okay, so that's what they're going to say in the question. They're going to say the graph reflected in the x-axis, what happens to the equation? So if a is negative, then direction change therefore reflected in x-axis. You'll see when we're doing the graph one. Now I'm just going to write next to this here for sine and cos. We know that the period is 360 divided by k. So they might just tell you in words that the period is something and you must figure out what k is from that. But for tan, remember it's different. For tan, the period is always 180 degrees divided by k. Okay, we know that the p-value is when we shift it to the left or the right. Okay, so shift to the left or the right. And then the q value, just the last one, is when the graph shifts up or down, when it is a q value, or the q value changes. Okay, I'm going to do an example now so you can see the type of questions that you might get. Are there any questions on this note that we've just looked at? Basically, just a recap of what we've done so far. Bring it all together. Okay, so consider the function f of x equals sine x. Right, so we're just starting with the basic sine graph. Write down the equation of okay, so guys, they've given us the equation of f, and now they're asking us for the equation of g. But what is g? G is the reflection of f in the x-axis. So as soon as you see that, I want you to think, okay, reflection in the x-axis, that means that the sign of A is going to change. Whatever your original A value is, all right, that sign is going to change. So let's write that down. That means that sign of A changes. What is my A value currently? 1. So now when I take that graph and I reflect it in the x-axis, it's going to become -1, negative sin x. I hope that makes sense, guys. If you have sin x, and you now take that graph and you flip it, you reflect it in the x-axis, that changes the direction. So instead of going up first, the reflection is going to go down first. That's what happens. And we know that when that happens, when we actually change the direction, we change the sign of A. So that means that h of x, sorry, not h, g of x is going to have an equation of negative sin x. Okay, so whenever you reflect in the x-axis, you change the sign of x. So guys, if it had a negative a already, then that would become positive. Okay, whatever the sign is, you just change that sign. Say this was -2 sin x. Now they say, oh, we're reflecting it in the x-axis. That's then going to flip up again. So it's going to become +2 sin. Okay, whatever that sign is, that just has to change. All right, number 2. Now we're finding the equation of h of x. If hx is the result, then if the 45 degrees to the left and 2 units down. Okay, so what was it? It was just sine x, right? Now that graph flips 45 degrees to the left. So what's going to happen to the equation? If it shifts to the left, we're going to have x plus 45, right? It's shifting in the negative direction, so we're going to have x plus 45 degrees. And then it's also shifting 2 units down. How do I show that in the equation? A minus 2. All right, so h of x is going to be sine of x plus 45 degrees minus 2. Make sure that you close that bracket after the 45 degrees. Okay, question 3 is a little bit different. In question 3, sorry, now it's not saying write down the equation of question 3 is kind of a question on its own. If the range of H and as you the range is with a y value, right? Now, if you have a picture of the graph, it's easy. You can look, what is the lowest y value, what is the highest y value? And the range is then y element of lowest to biggest, smallest to largest, minimum to maximum. Now we don't have a picture of the graph. Okay, I don't suggest that you draw the graph. What you can do is you can use the table function, put that equation in, all right? From it's difficult here because now if it's shifting 45 degrees to the left, your starting point is actually at negative 45. All right, so if you wanted to do that, you would have to take that into consideration. But let's see if we can visualize, if we can figure it out without using a calculator, without actually drawing it. This is sine x plus 45 minus 2. But the 45 degrees is not actually going to have any effect on the range. The range is affected by that minus 2 shift. What is the range of a normal sine graph? If it's just sine x, what is the lowest value of sine x? Negative 1. Hey, and the highest value is positive 1. So we can write that. We can say, okay, the range of x, the range of the basic sine graph, which remember I said it's good if you memorize how that sine graph looks, because then you'll be able to do these questions quite easily. So the range of x, which was just y equals sine x, is from negative 1 to 1. Now, if you have that graph with that range and shifted 2 units down, the values of the range are also going to shift 2 units down. Okay, if the original lowest value was negative 1, and that whole graph is now shifting 2 units down, that would be negative 3. Right? That lowest value of that graph. Because our lowest value is a negative 1. It doesn't matter that it's shifted to the side. Okay, it has shifted to the side, but we're just thinking in terms of lowest value and highest value. That's all we need to put in our range. So the original lowest value is negative 1. That is now going 2 units down. So that's going to be -3. All right. So what you're actually going to do is you're now going to say -1 minus 2 to get the new one. And your new maximum value, it was 1, but that is also shifting 2 units down. So to get the new maximum value, you're also going to minus 2 from that. That whole graph is keeping the same shape. It's just going 2 down. Okay. So the new range, therefore, the range of h is going to be y is an element of -3 to -1. All right, the original lowest value -2, and the original maximum value also -2. If you were moving up by 3, you would add 3 to both of your original range values. Okay, whatever you're shifting up or down by, you just change, you add or subtract from your original range. Let's just see what other types of questions. Okay, that's kind of it. I think, yeah, these are mostly like the types of questions. They ask you to reflect in the x-axis, then you change the sign of A. They can do a shift to the side, a shift up or down. Then you do this kind of thing. They can ask you for a range of the graph, right? Then you must just shift the range as well. So I want you guys to practice a few of these questions on your own. So it's exercise 9 in the textbook. It's on page 131. Let's do numbers 1, 2, 4. Yeah, 1, 2, and 4. And I just want to change. Sorry, I'm just looking here. Guys, for 3.2 here, I just want to change the wording of that question just to find the equations of the graphs, because they have written the equations in a strange way, which I don't like. So I'm just going to say find the equations of F, E, H, and J. So guys, H and J are actually asymptotes. They're not like full trig graphs. So those equations are just going to be x equals whatever, like whatever x value it cuts. That's going to be the equation of H and J. So you'll just have to figure out what those values are. So it's values. But guys, you can still answer the rest of the questions if you are not able to find all of those equations. Okay, so don't think, oh, I don't know what these equations are, I can't answer the others. You can still try. And you're just doing the first 4. There are 7 questions in that exercise. I just want to do 3.1 to 2. Yeah. Yes. I'm just going to put the questions for exercise 9 on the board. Just write this down quick, you guys, so I can take it off. Okay, well, sorry, that's the dot. Let's see. All right, you're doing 1, 2, and 4 of this exercise. That's exercise 9. But then obviously the other exercises are on a different page.